Hello everyone. In this video we're going to be integrating a radical function. Looks like I forgot the integral sign, so here we go. We're going to integrate dx over the square root of x minus x squared. Now how do you integrate something like this? Well, I'll be presenting two methods, even though I had an attempt for a third method which I'll probably share with you, but I didn't get to the end. Anyways, let's start with the first method. So we're going to integrate dx over square root of x minus x squared. Now, for my first method, I'm going to separate this into a product. So square root of x minus x squared can be written as the square root of x times 1 minus x. And then we can go ahead and separate this into two radicals like square root of x times the square root of 1 minus x. Okay, now, here's what we're going to do. We're going to be writing this as 1 over square root of x times the square root of 1 minus x. Now, what is so helpful about separating them? You might be thinking, right? So here's what I'm going to do. The square root of x, I'm going to call that sine of an angle. And you'll see why in a little bit that's the case. So sine t is just going to be square root of x. Makes sense? And now when you square this, you're going to get sine squared t equals x. And then cosine squared is just going to be 1 minus x, which is 1 minus sine squared. And then cosine from here is going to be the square root of 1 minus x. Ignore all the positive negatives. Let's just write it as is. Now, what is that supposed to mean, though? Well, since sine squared t is equal to x, we can basically write that into our equation. So x is replaced with sine squared t. You see what I'm doing? But of course, we're going to find dx from here. Now, if you did it directly, what would happen? You would get sine squared minus sine to the fourth power, and then you would factor out sine squared, and you will get the exact same thing. But it would be hard to see that that is the right formula to use for substitution. So let's go ahead and evaluate dx from here. Since x is equal to sine squared t, dx is just going to be the derivative of sine squared t, which is 2 sine t, and then the chain rule says the derivative of the inside, and then finally dt, right? So let's go ahead and plug in everything. Dx will be replaced with 2 sine t cosine t dt. And then remember, we had the square root of x and square root of 1 minus x. Square root of x is just going to be sine t from here. So this is going to be sine t, and the other factor is just going to be cosine t. How nice, right? Pretty convenient. And then sine t and cosine t are both going to cancel out, leaving us with the integral of 2 dt, which is just 2t plus a constant. But what is t? We never talked about t, right? Easy. If x is equal to sine squared t, or if sine t is equal to square root of x, you can kind of use the inverse sign, right? Sine inverse of square root of x equals t. So that's what you need to replace t with. And now our integral is just going to be 2 times sine inverse of square root of x plus a c. And of course, some people are going to write this as 2 arc sine square root of x plus c. Exact same thing. It's just a different notation. So this is the integral of dx over square root of x minus x squared. Kind of surprising a little bit, right? Well, not really, because when you have the square root of something in the denominator, it's usually arc sine or something like that. Okay, and obviously, you can also write this in a different way, which I'll show you towards the end, and we'll talk about that as well. But let's go ahead and take a look at the second method. Okay, for my second method, let me rewrite the problem. We have the integral of dx over square root of x minus x squared. So we're going to be using something pretty interesting. Let's start with x minus x squared, and then write it as the opposite of x squared minus x. So my goal is to complete the square. Remember how we complete the square in a quadratic? You basically add, look at the coefficient of x, you take half of that, let's call that b, like if you have x squared plus bx. What's half of b? b over 2, and then you square it. That's the number you need to add to complete the square. Of course, you also have to subtract it, right? Otherwise, this is going to be incorrect. So here's what we're going to do inside the parentheses. We are supposed to add half of 1 squared, which is 1/4. And that makes a negative 1/4 because there's a minus sign. Notice that. So I'm supposed to add 1/4 to undo the subtraction of 1/4. Makes sense? But notice that the expression inside the parentheses becomes a perfect square, and that's just perfect. So this is x minus 1/2 squared plus 1/4. And of course, you can write this as 1/4 minus x minus 1/2 squared. And what does that remind you? Especially under the radical, that should remind you sine of something. So we're going to use trigonometric substitution, and we're going to replace x minus 1/2 with the something times the sine of something. The reason being is whenever you have square root of a squared minus y squared, y is usually replaced with a sine theta. Cosine is also going to work, but I like the sine better, okay? Because its derivative is positive, sort of. I mean, it has a plus sign. It's not always positive, but you get the idea. Uh-oh, it just came back magically. So, let's go ahead and do it then. X minus 1/2. What should I replace minus 1/2 though? You have to be careful about this number here. This is 1/2 squared, so I do need a 1/2 times sine theta. So when I square this expression, then I'm going to get 1/4, which is going to be able to factor out. Make sense? Okay, but of course this is just x minus 1/2, so I'm going to find dx from here, which is 1/2 cosine theta d theta. Don't forget to differentiate it and add the d's. Okay? Now let's go ahead and see what happens. We have square root of x minus x squared in the denominator, and dx will be replaced with 1/2 cosine theta d theta, and inside the radical we're going to have x, which is what? Okay, this is x minus x squared, and notice that I'm replacing this with 1/2 minus sine. So now we have 1/4 minus 1/4 sine squared theta, right? And then, of course, there is a plus c. Don't forget that. 1/2 cosine theta d theta divided by, now we're going to be able to factor 1/4 out, and this is going to give us 1 minus sine squared. If you square root them separately, uh-oh, I was trying to erase with my fingers. That didn't work. And we can go ahead and just write this as the square root of cosine squared, which is cosine, so we're going to be able to cancel these out. And this is 1/2. We're going to cancel these out. Again, we end up with something super duper simple. Integral of d theta, which is theta plus c. But what is theta? That's what we got to find out, right? Well, let's see. X minus 1/2 is 1/2 sine theta. So from here, what do we get? X minus 1/2 is 1/2 sine theta. We could probably multiply both sides by 2. That's going to give us 2x minus 1 equals sine theta. And then we can do the little, what is that called? The inverse sine thing. So the inverse sine of 2x minus 1 is just going to be theta. So that is the answer. Well, wait a minute. What happened to the square root, right? Well, you can kind of find out what happens with something like this. Okay, so theta is going to be from here, sine inverse of 2x minus 1 plus a constant. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.